What is the trigonometric sine ratio? Well, to see this ratio, let's start off by taking a look at these two right triangles. Let's take a minute and compare these right triangles and see what we come up with. Well, let's take a look at their sides. Here, we have a side that measures 6. Let's write that down. Now, if we look over here, this side measures 3. Let's write that as a ratio. Let's put 6 over 3. Okay, great. Now let's do that same thing with the other sides in these two right triangles. Here, we have a side that measures 10. And here, we have a side that measures 5. So let's do this, 10 over 5. And here, this side measures 8, and this one measures 4. So let's put 8 over 4. Now look at what we get. 6 over 3, 10 over 5, and 8 over 4 all reduce to the same thing. They're all equal to 2. Neat. And if we look, we were dealing with corresponding sides. So corresponding sides are proportional. That means that these two right triangles are similar figures. And if we have similar figures, not only are corresponding sides proportional, but corresponding angles are congruent. They have the same measurement. So if we take a look here, angle B and angle E, those are both right angles. They have the same measurement. Those are congruent to one another. Perfect. And if we continue to compare, C and F are corresponding angles. Those are also congruent to one another. And so is angle A and angle D. Great. Now that we know that these are similar figures, let's take a look at just one of the triangles. Let's play around with just the sides of that triangle. So let's take this side length again, 6. Let's take that and put that in a ratio over this side length, 10. So we'll take 6 and put it over 10. Now, what if we set up the same ratio, but with the corresponding sides in this right triangle? Well, here, the side that corresponds to this one is this, 3. And if we look, the side that corresponds to the one that measures 10 measures 5 over here. So if we set that up as the same ratio, we get 3 over 5. Well, 6 over 10 and 3 over 5, those are equivalent fractions. They have the same value. They're equal. That's really neat. And it turns out this will have the same effect if we find any other similar figure to this one. That ratio actually has a special name. The ratio that we just found is called the sine ratio. Now, the sine ratio works in general for any right triangle, not just right triangles that are similar to these two. So to help us see the sine ratio, let's take a look at a general right triangle, like this one here. Now, to find the sine ratio, we need to take the ratio between two specific sides of a right triangle. Those sides are specific to a certain angle. So say we want to take sine of angle A. We want to find that ratio. So we're actually talking about this angle, angle A. Now to find sine of that angle A, we need to take the ratio of the opposite over the hypotenuse. Now what does that mean? Well, the opposite is the measurement of the side that sits opposite the angle that we're trying to find the sine of, angle A in this case. The hypotenuse is the measurement of the longest side of the right triangle. Now, if we want to see that in our general triangle, we can. First, let's look at the hypotenuse. That's the measurement of the longest side. It always sits across the right angle. So, this length right here is the hypotenuse. Now, the side that sits opposite A, we can find by taking a look at angle A and just going to the opposite side. So, here, this is the opposite side. Great. Now, if we want to see this with our example, we can. Let's take a look back at our first triangle and find sine of angle A. So we're now trying to find sine of this angle, that ratio. So we need to find the measurement of the opposite side, which is 6, and the measurement of the hypotenuse, the measurement of that longest side, 10. So we get that sine of A is equal to 6 over 10. Well, 6 over 10 reduces to 3 over 5. And if we compare that to our second right triangle, we can see that that's the same as sine of angle D. And remember, angle A and angle D are congruent angles. They have the same measurement. So, between similar figures, those corresponding angles will always have that same ratio. Neat! Now, what if we wanted to find sine of a different angle in our right triangle? Like, say, for instance, C. Well, we could do that as well. This sine ratio that we have works in general for right triangles. So it's specific to the certain angle that we're looking at. So let's say now that we take a look at this first triangle and we want to find sine of angle C. Well, again, we need to find the measurement of the opposite side to C and the measurement of the hypotenuse and write them as that ratio. Taking a look at angle C, we look across and we see this side. That measures 8. So that's the measurement of the opposite side. And the hypotenuse is still 10, because it's that measurement of the longest side. So we get the ratio 8/10. Well, if we end up simplifying that, we get 4/5. And if we take a look at our second right triangle, that is the same as sine of angle F. Taking a look at angle F, we have the opposite over the hypotenuse, 4/5. And look, angle C and angle F are congruent angles. So now we know about the sine ratio. If we have a right triangle and we want to find sine of a certain angle, we need to simply find the ratio between the measurement of the opposite side of that angle and the measurement of the hypotenuse.